Alright, so Merry Christmas everyone. You're all welcome back to this channel, Learn Maths, right? Today we're going to be looking at a new topic on mathematics, which we're going to use to keep ourselves busy, to spicing up the Christmas holidays. We're going to be looking at a very new topic today, and that topic is going to be matrix, alright? We're going to look at matrix today, which happens to be one of the difficult topics in mathematics, but today we're going to treat it right to your understanding. So let's get right to it. Alright, so before we proceed, do well to get a pen and a book so you can take down some notes as we go on, right? So now let's start with the definition of a matrix. A matrix is an arrangement of elements enclosed in a rectangular bracket, right? An arrangement of elements enclosed in a rectangular bracket. Now in this case, our elements are going to be numbers, not alphabets. This mathematics, we deal with numbers, right? So our elements in this case are going to be numbers. Now let's look at some example of matrix. Now the first example we have here is this 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see how the numbers are arranged in the bracket they are showing on the screen. See how they are arranged, right? Now this matrix, this example we have here now, is a square matrix. Why? Because it has equal number of rows and columns. Now look at the first row there, made up of 1, 2, 3, made up of the numbers 1, 2, 3. Look at the second row, made up of 4, 5, 6, right? And look at the third row, made up of 7, 8, 9. You understand? 7, 8, 9. So it has 3 rows. Now let's look at how many columns it has. It has 3 columns as well. 1, 4, 7, 2, 5, 8, and 3, 6, 9. Those are the columns, right? So this kind of matrix that has equal number of rows and equal number of columns, these matrices are called squared matrix. In fact, we have different types of matrix, right? Now look at this example here. I have 2, 4, 1, 6, 7, 8, right? 2, 4, 1, 6, 7, 8. Now if you look at this matrix, you observe that we have like 2 rows, right? The first row is 2, 4, 1, and the second row is 6, 7, 8, right? 2 rows, but we have 3 columns. That's 2, 6, the first column, 4, 7, the second column, and 1, 8, right? So this will be called a 2 by 3 matrix, right? It will be noted as a 2 by 3 matrix. That is 2 times 3. The 2 there stands for the number of rows, while the 3 there stands for the number of columns, right? Let's look at another example here. Okay, we have 1, 1, 0, 2, 6, 7, 8, 13, right? 7, 4, 5, then we have a fraction 2 over 9, right? Now let's look at this. What kind of matrix is this? Like, what is it going to be noted as? Denoted as, right? Now let's see how many rows and how many columns we have. We have 1, 2, 3. Okay, we have just 3 rows. The first row being 1, 1, 0, 2. The second row 6, 7, 8, 13, right? The third row 7, 4, 5, then the fraction 2 over 9, right? So we have 3 rows. Now let's see how many columns we have. 1, 2, 3, 4. Okay, we have 4 columns. What are they? The first column 1, 6, 7, right? The second column 1, 7, 4. Alright, the third column 0, 8, 5, right? Then finally the fourth column we have 2, 13, and the fraction 2 over 9, right? Alright, so since this matrix has 3 rows and 4 columns, it's going to be denoted as a 3 by 4 matrix, right? That's 3 times 4. Right, so for today's matrix, which happens to be the topic we are treating, I just noticed that matrix is a very long and difficult topic, right? So it may not be possible to finish matrix completely and everything about matrix today on this video. So these are the major points we are going to be looking at. We are going to be looking at addition of matrix, right? Addition of matrix, subtraction. Okay, let's just say addition and subtraction. Subtraction, addition and subtraction of matrix. Then we are going to be looking at multiplication and division as well, right? We're going to be looking at addition, subtraction, multiplication, and division of matrix. Alright, and thirdly, we are going to be looking at matrix multiplication, right? Matrix multiplication, and then determinants. Okay, these are like the major things we can look at today: addition and subtraction of matrices, multiplication and division of matrices, then matrix multiplication of matrices, then determinant of matrices. These will be our key points for today. So before we proceed with these points, I would like us to look at more types of matrix, right? I would like us to be familiar with more examples of matrix. Alright, so on types of matrix, we already looked at squared matrix, right? But these are the 4 major types I want us to be familiar with during the course of this lesson, right? There are other types of matrix, but I need us to be familiar with these 4 major types. Now, starting with square, let me just refresh your mind on the square matrix, right? I said a matrix that has equal number of rows and equal number of columns. That's the square matrix. Now, if I have 0, 1, 5, 2, 3, 4, right? Now, let's see if this is a square matrix. I have 1 row, 2 rows, right? I have 2 rows. How many columns do I have? 1, 2, 3. I have 3 columns. So this is not a square matrix because it's denoted as a 2 by 3, not 2 by 2 or 3 by 3. So this is not a square matrix. If I'm to make this a square matrix, I will have to add another row, right? So let's add something to it. 5, 5, 7, right? 5, 5, 7. Now, how many rows do we have? 1, 2, 3. 3 rows, right? How many columns do we have? 1, 2, 3. 3 columns as well. So this is square matrix. You understand? This is square matrix. Another example of a square matrix. We have 1, 2, 3, 4. Right? This is a 2 by 2 square matrix. We have 3 by 3, 4 by 4, 5 by 5, and so on. Now let's go to zero matrix. Let's move on to the next slide, which is a zero matrix. Now listen. A zero matrix is a matrix that has just 0 as its content, right? The elements in the zero matrix are all zeros. Now look at the zero matrix. 0, 0, 0, 0, 0, 0, right? This is how many rows? 1, 2, right? 2 by 3 zero matrix. This is a 2 by 3 zero matrix. We could have a 3 by 3 zero matrix. We could have a 4 by 4. We could have a 1000 by 1000 zero matrix. Have a 100 by 100 zero matrix. Just know that a zero matrix is a matrix with zeros as the only element. You can't find one, you can't find the other number, just zeros, right? Now let's go to identity matrix. Let's look at the next type, an identity matrix. Now, an identity matrix is a right diagonal matrix. We need to talk about diagonal matrix, but I believe with this you're going to understand what the diagonal matrix is. Now, an identity matrix is a right diagonal matrix with just 1 as the only non-zero entity. That's if you're seeing a number that's not 1, that's not 0, sorry, it's going to be 1. Right, so this identity matrix is going to be made up of just zeros and 1, like binary, right? Just zeros and 1. But now, before I proceed with the identity matrix, let's look at what a right diagonal matrix actually means. Now, this is a right diagonal matrix 3, 4. Okay, you can see this is a square matrix, right? A 3 by 3 matrix, as we all know. But now, this is a right diagonal matrix. Reason being that the numbers that are not 0, that is the non-zero entities, are forming a right diagonal, right? That's why we call this a right diagonal matrix. Look at this number 2, 3, 4. They are not zeros, right? They are solid numbers and they are forming a right diagonal. Now for a left diagonal, we're going to have something like 1, 5, 7, right? And this is a left diagonal because the numbers that are not 0 are forming a left diagonal. Can you see that line? That diagonal line, right? This right diagonal, this left diagonal. Now back to identity matrix. Back to identity matrix, which is one of the major types I want us to be familiar with. Now, it is a right diagonal matrix, right? But this time around, if you are not seeing 0, you are seeing 1. You can't see 2, 3, 4, 5. You just zeros and 1, right? Now, this is a 3 by 3 identity matrix. This is a 2 by 2 identity matrix, right? Okay, let's look at 4 by 4. is a 4 by 4 diagonal, sorry, this is a 4 by 4 identity matrix because this is 4, this is 4, right? Then this is the right diagonal, which is made up of 1, right? Now we look at square, 0, and identity matrix. Finally, let's look at the singular matrix. Take note of this. A singular matrix is a matrix that has 0 as its determinant, or is a matrix that has no determinant. And since I have not explained what a determinant actually means, then I can't give you an example, right? When we talk about determinants, then I'm going to explain for you what the singular matrix is. But for now, we haven't talked about determinants, so I can't really give an example for this kind of matrix. We just know that a singular matrix is a matrix that has 0 as its determinant, or a matrix that has no determinant. Alright, so let's proceed with addition of matrices. Let's proceed with addition then. Alright, so starting with addition and subtraction, let's look at this example, right? Now look here, we have two matrices. This is a 2 by 2 matrix, right? This is also a 2 by 2 matrix. Now I want to add this 2 by 2 matrix with this 2 by 2 matrix. So what's going to be the answer? We're going to have 2 plus 1, right? 4 plus 0, 5 plus 4, then 6 plus 5, as easy as that, right? So let's proceed with this 2 plus 1, right? 2 plus 1, then 4 plus 0, okay? 5 plus 4, and finally 6 plus 5, 6 plus 5. So this is going to be the final answer. 2 plus 1, 3, right? 4 plus 0, this is 4. 5 plus 4, 9. Then 6 plus 5, that's 11. Alright, so this is the answer, as easy as that. This matrix plus this matrix give us this as an answer, right? Alright, so the previous example was on addition. Let's take another example, but this time around for subtraction. Alright, so let's look at this. We have this matrix subtracting this matrix, right? This minus this. Okay, so what's going to be the answer? We're going to have 5 minus 3, right? 5 minus 3. I hope this is clear. And we're going to have 2 minus 1, right? 2 minus 1. Okay, if you notice, this is a 2 by 3 matrix. Use also a 2 by 3 matrix, right? The matrix has to be similar, the annotation has to be similar before you can carry out addition or subtraction. Alright, so this is 5 minus 3, this is 2 minus 1, then this will be 1 minus 0, right? 1 minus 0. Now here we're going to have 0 minus 4, right? 0 minus 4, then 3 minus 2. Then finally 3 minus 5, right? 3 minus 5. So let's see what the resulting matrix is going to be. Now 5 minus 3, that's 2, right? 2 minus 1, that's 1, right? 1 minus 0, that's 1 as well. Then 0 minus 4, that's negative 4, right? 3 minus 2, that's 1. Then finally, 3 minus 5, that's negative 2, right? 3 minus 5, negative 2. So this is the resulting matrix. This minus this is the answer, right? This is the resulting matrix. And this one is subtracted from this one, okay? Alright, so basically that's all about addition and subtraction of matrix, right? That's how easy it is, but some of you might get confused when you're faced with this kind of situation. So let me just put it straight and explain this to you. Now look at this matrix, subtracting this matrix, right? This is a 2 by 2 matrix, right? 2 by 2, this is a 2 by 2 matrix. 2 rows, 2 columns. Then this is a 2 by 3, right? 2 rows, but this time around 3 columns. Now listen, these two matrices are not commutable, they are not compatible for addition or subtraction. Reason being, now if I add this, okay, that's subtraction. If I subtract this from this, that's 5 minus 3, then 2 minus 1. What number am I going to use to subtract this 0 there? Okay, then if I say 0 minus 4 and 3 minus 2, what number am I going to use to subtract this 5? So these two matrices are not compatible for addition or subtraction. You should know when to add and subtract. You should also know when addition and subtraction is not possible, right? So let's move on to multiplication and division. division of a matrix. Alright, so moving over to the next subtopic, multiplication and division of matrix, right? Now, actually, it's called scalar multiplication and division of a matrix. Reason being that we are using a number as the scalar to multiply a matrix, or we are using a number which is still the scalar to divide a matrix. Now, take a look at this example. If I have 2, right? If I have 2 times this matrix, let's say 4, 5, 6, 1, 2, 3, 0, 4, 3, alright? Now look, I have 2 times this matrix, right? Now this is the scalar, that is the number multiplying this matrix, right? The scalar here now in this case is 2. It could be 3, it could be -5, it could be whatever number you choose to keep there. But since we have it 2, let's see what the resulting matrix here is going to be, right? Alright, so the resulting matrix is going to be this, right? 2 times 4, 8, right? 2 times 5, 10, 2 times 6, that's 12, right? 2 times 1, 2, 2 times this 2, 4, right? 2 times 3, 6, 2 times 0, that's still 0. 2 times 4, that's 8, right? 2 times 3, finally, that's 6. So, if you multiply this matrix here with the scalar 2, this will be your answer, right? That's how easy it is. So let's move over to division, right? Let's move over to division. Alright, so for division, that's still scalar division of matrix, right? This is going to be like the last easy part of matrix we're going to discuss, right? So let's just get over with it. This matrix here, 4, 8, 16, divided by 2, right? This matrix is being divided by this scalar 2. So let's see what the resulting matrix is going to be. This is 4, right? 4 divided by 2, now that's 2. 8 divided by 2, that should be 4. And 16 divided by 2, that's 8, right? 6 divided by 2, that's 3. 5 divided by 2, that should be 2.5, alright? And 3 divided by 2, that's 1.5, right? 2 divided by 2, that's 1, right? 10 divided by 2, 5. 12 divided by 2, that's 6 finally. So this is the resulting matrix you get by dividing this matrix with this scalar 2, right? So, alright, so that will be the end for this video, right? There's more to matrix we haven't actually dealt with, but for today we're going to stop at multiplication and division. That's scalar multiplication and division. To make the video short, so we're going to have time to enjoy ourselves for the rest of the day. I wish you guys a Merry Christmas and of course a prosperous New Year. During the next video, we're going to talk more on matrix, right? The leftovers, the remaining topics, we're going to treat the rest of them in the next video. But for today, let's just stop there and that will be it for today. So before we leave, please do it to like this video, subscribe to this channel, and share this video as well, right? So bye, Merry Christmas.